Welcome back to part 2 of Module 7, Lesson 7, where we're continuing our study of multiplying and dividing inequalities, but now we're focusing on negative coefficients. And remember, the coefficient, that's a fancy word we use to describe the number in front of a variable. Here we have the problem where you have negative 2x is less than 10. Your coefficient is going to be that negative 2x, okay? That's the part that's important here with what we're focusing on. We're going to treat it just like we would treat an equation, almost. We're going to isolate the variable. The variable is x. X's friend is going to be negative 2. Negative 2 is multiplying x, so we're going to divide both sides by the negative 2. But the important thing to notice is what happened to that inequality symbol there. When I divided both sides by a negative number, in this case being negative 2, my sign went boop and changed directions on us. Other than that, this works just like every other equation in inequality you've ever touched. From here, the negative 2's on the left, they're going to divide each other out, becoming 1. 1 times x is x. Positive 10 divided by negative 2 is going to be negative 5. So your final answer, x is going to be greater than a negative 5. Easy math. Anybody can do this. That's showing your work. The biggest thing you got to do, your biggest challenge with this is remembering when do you flip the sign and when do you leave that sign alone. To graph it, you're going to do the same thing we've been doing with all of our other graphing. X is a value greater than negative 5, so we're going to start with an open circle because it's greater than, but not an or equal to. And because we're going greater than, it's going to be the arrow going to the right. Answer checks. Easy math. You can do this stuff. And you're going to get a chance to do this stuff. When we move on, you're going to be working extra example 3 on your own. Go ahead and pause the video and work on this problem. So how'd it go for you? For me, this will be super easy. I'm going to take and isolate the variable, dividing both sides by the variable's friend, which is negative 5. We're dividing it because it was multiplying. I'm sorry, negative 2.5. The negatives divide each other out. 2.5 divided by 2.5 is 1. 1 times y is y. And here comes that piece of magic we got to focus on. Because I divided both sides by negative, the sign changes directions. It only changes directions when you multiply or divide both sides by a negative number. Now I'm going to come off to the side and do some scratch work. 2.5 goes into 8. Well, first we need to take and bounce that decimal against the wall. Decimal inside the house goes the same number of times to the right. Annex zeros and move it up. 25 goes into 80 3 times, which is going to leave us with, oops, I wrote the wrong number there, 75. Subtract that out, you get 5 left over. Annex in a 0 and bring it down. 25 goes into 52 times, which is 50 with nothing left over. So our answer is going to be that y is now less than a negative divided by negative is a positive, so it's going to be a positive 3.2. Jump back over here to our problem. We have less than, was it or equal to? Oh, it was an or equal to. Mr. Reach screwed up. Got to put that or equal to symbol in there. So we're going to be less than or equal to 3.2. Check that. And then we're going to come down here and graph it. It's an or equal to, so it gets a solid circle. Start at 3.2 and go to the less than side, which is right there, and check our answer. The answer checks. Easy math. Example 4 is going to be very similar, only we're starting with a division problem. And how do you undo divided by a negative 4? By multiplying negative 4 on both sides, just like we did with if it was an equation. So we're going to take our original problem here, and we're going to multiply negative 4 on both sides. Now, 2 things to point out. 1, take that negative 4 and move it after the number you're multiplying it by. Trust me, you will thank me later in life for this, even if you don't realize it. And then right here, where you have the greater than, we turn that sign around, making it a less than, and it's an or equal to as well. The negative 4's on the left divide each other out, and on the right, negative 4 times a positive 3 is going to give us a negative 12. So now I have x is less than or equal to a negative 12, check, and it checks. Therefore, the solution of the inequality is x is less than or equal to negative 12. So we're going to take and graph that. So let me grab a hold as an or equal to. It's going to be a solid circle. Let's get a nice shade of blue here. And we're going to take in at the negative 12, x is less than or equal to, so it's going to go that way. And my answer checks. There is nothing at all to working these problems. And that means you need to work one as well to show me you understand it. So your problem, extra example 4, says a divided by a negative 1.2 is greater than negative 4. Go ahead and work that problem, check your answer, and it looks like they're going to want you to graph it as well. Get started. So how'd that problem work out for you? Let's see how it works out for me. We're going to take and put it up here on my slate, get some nice clean real estate, and yep, that looks like our problem there. Whoops, didn't mean to do that. So we're going to take, and there we go. The variable is a, his friend is a negative 1.2. Negative 1.2 is dividing it, so we're going to undo divided by negative 1.2 by multiplying a negative 1.2 on both sides. Only I'm going to do it the right way. I'm going to put it after the number I'm multiplying it by, because I don't want to screw up later in life when I'm doing these same kind of problems with subtraction and just totally mess up my whole world. So times a negative 1.2 here. From there, these divide each other out. The negatives divide each other out, leaving a. And I should have changed this up here where I did it. That sign should have changed directions because I multiplied both sides by a negative number. From there, a is now less than 4 times a negative 1.2. Negative 4, that's going to become a positive 4.8, I think. But let's just make sure here. 1.2 times 4. 4 times 2 is 8. 4 times 1 is 4. Bounce our decimal 1, 1. Yep, it's going to be a positive 4.8. A is less than positive 4.8, which we're going to plug in right here. We got it less than a positive 4.8, and check. That checks. And now we need to graph that problem. So we're going to have an open circle. I'm going to start at 4.8, and we're going to go to the left-hand side, and that checks as well. Now, example 5 involves word problems with an elephant wash going on here. Ling earns $15 an hour working at the zoo. Write and solve an inequality to determine the number of hours Ling must work in a week to earn at least, that means she can earn greater than, or equal to $225. Then interpret the solution. So, think about what it's asking us to do. First thing in words, we're going to look at it, and we need to say that the total amount earned, per hour times the total number of hours worked has to be at least, that means greater than or equal to, the amount earned each week. If we were to take a variable, they let x equal the number of hours. I would have used h, just seems more appropriate. And then from here, we have got the inequality that $15 an hour times x hours is greater than or equal to $225. That's how we lay it out. To solve it, all we have to do is isolate our variable, dividing both sides by the 15. 15 is a positive number, so we're not going to flip the sign. We only flip the sign when we multiply or divide both sides by negative. From here, the 15s on the left divide each other out, leaving x is greater than or equal to 225 divided by 15. Well, I'm going to need to do a little bit of grunt work on that one. So I'm going to take and set up my problem. 225 divided by 15. 15 goes into 22 once, which is going to leave me with 7 left over. Bring down the 5, and that's going to be, I believe, 7. Nope, not 7. 5 times. 5 times 5 is 25. 5 times 1 is 5 plus 2 is 75. Yep, so my answer is going to be that x is greater than 15 hours. Check it. She must work at least 15 hours in order to make that $225 she wants to make. Now to graph it, we're going to take, and it's a greater than or equal to, so we're going to use a closed circle. We're going to take and grab right there, drag to the greater than side, and check. And the answer is correct. Easy math. You totally can do these problems. Now it is your turn Pause the video, work extra example 5 right here on your own. How'd it go for you? Alex and Rowan are going on a 6-day hiking trip. They plan on hiking the same distance each day. They want to hike at least 75 miles total. Write and solve an inequality to determine the total miles they will hike each day, then interpret the solution. Now, if you think about this, the total is going to be at least, that means greater than or equal to 75. We've got 6 days to do it, and every day we're hiking the same number of miles. So 6 times the same number of miles each day has to be greater than or equal to that 75 I've got over here. So what do we have here? 6 times that some number of miles is less than or equal to. That one's not going to work. The number of miles divided by 6, definitely no division here. 6 times some number of miles is greater than 75. That, I need to switch back over to here. That is going to be the exact equation we're looking for. And now we have to solve our inequality. So we got 6 is greater than or equal to 75. 6x, excuse me. I'm going to isolate my variable by undoing multiplication, dividing by 6 on both sides. 6 is positive, so my sign is not changing directions. 6 divided by 6 is 1. 1 times x is x. Come off to the side and do some grunt work here. 6 goes into 7 once. 1 times 6 is 6 with 1 left over. Bring down the 5. 6 goes into 15 2 times, which is going to be 12 with 3 left over. Annex in a decimal and a 0. The decimal goes up. Your 0 comes down. 6 goes into 35 times. 5 times 6 is 30 with nothing left over. So your answer is that each day they have to hike at least greater than or equal to 12.5 miles. So right here, we got our greater than or equal to 12.5. Check that. That's good. And finally, they need to have, there it is, at least. Check our answer. The answer checks. Easy math. You guys can do this stuff. It's really not any harder than working multiplication and division equations. And we are finally on our last pair of examples, starting with example 6, where Miss Miller is buying wax to make candles. She wants to make at least, that means greater than or equal to, 35 candles, and needs 6.5 ounces of wax for each candle she makes. So from there, write and solve an inequality to determine the amount of wax she needs in order to get the solution. So from there, lay out your inequality, where they took and said that the total amount of wax divided by the 6.5 ounces of wax in each equation, that number is going to be a value greater than or equal to the 35 candles she wants. From there, they undid division by multiplying both sides by 6.5. Remember, do it after the number, not before it. And then the 6.5 divide out, leaving x was greater than or equal to 227.5. So right here, 227.5 is how many candles she would make. I guess one of them would just end up being a little bit short. If you were to graph that, we're going to take and let's zoom out a little bit. That was a x is greater than or equal to, solid circle, 227.5 goes to the greater than or equal to side. Check your answer. Nothing to do on these things, guys. You know how to do it. Make them count. Now you're on extra example 6, the last problem for you to work on your own. Go ahead and pause the video, work this one, and check your answers. Carmen is buying ribbon to make wreaths. She wants to make at least 20 wreaths, greater than or equal to, and needs 10.25 inches of ribbon for each wreath. Write and solve an inequality to find out how much ribbon she would need to buy. Interpret the solution. Well, what do we know? We know she has a total amount of ribbon that she's dividing into 10.25 inch sections, and that's got to give her a value that is greater than or equal to the 20. So our solution is going to be B right here. So let's jump over and plug that in. Come on, let me find it, make it work. There we go. That's the right slide. Hit check. That checks. And now we're going to take and work that solution by isolating that variable. So we check B right here. And there we go. So I'm going to take x divided by 10.25 is not equal to, common mistake, greater than or equal to 20. I'm going to isolate the variable by multiplying both sides by the 10.25. So I have x divided by 10.25 times a 10.25 is greater than or equal to 20 times the 10.25. These divide each other out, becoming 1. 1 times x is x. Notice that sign did not change direction because I multiplied both sides by a positive number. And then from there, 20 times 10.25, well, that is going to give me 205, if I did that math right in my head, a value where it says x is greater than or equal to 205. Now let's see if we have an option for an answer like that. Greater than or equal to 205. That checks. And finally, last thing we need to do is interpret it. She needs to purchase at least 205 inches of ribbon. That is it for this lesson. Get started working on your homework. Give me good quality big kid supporting work so I can give you good quality big kid grades. I'll see you in class tomorrow.